So let's look at question number 12 then. So what they have said here is for a certain amount of an ideal gas. So whenever they start with the term certain amount, what does it mean is mass is maintained as a constant. Okay. The mass is maintained as a constant. Now the pressure is varied with the temperature. Okay. So I think I just gave them as a short note. So if you look at here, PV is equal to nRT. When temperature is a constant, anyways n is a constant, we'll be having PV is equal to constant. Now why I say temperature is a constant is, you can see temperature is not varying. So PV equal a constant mean it is your Boyle's law. So just remember, in a PT graph, if you have vertical lines, it denotes your Boyle's law. Now you can see there is a nice y equal mx format graph. It's either y equal mx plus c or y equal mx. But you can see it's in a nice y equal mx format. The gradient is a constant. So if you want to have a gradient constant, pressure is my y-axis, nr over v. This is my y. This is my x. This part has to be a constant. Clear? This part has to be a constant. So then only you can have a constant gradient, which means my v is a constant here. If you are having curves, then it's a problem. If I have a curve, the gradient is changing, of course then the volume is changing. But if you are having m a constant, the volume is constant in here. This represents the pressure law. Okay. So if I just draw the graph for Vt, if I just draw the graph for Vt, the volume is reducing. So the pressure is reducing. PV is equal to constant. So pressure is inversely proportional to the volume. If the pressure is reducing, the volume should increase at constant temperature. Now, in here the volume is a constant. Now again the volume has to increase. So your answer has to be answer number 4, okay? So just remember them. If you want to eliminate answers quickly, you know it's a pressure law. So if the pressure is reducing, volume has to increase. So the two arrows has to be moving upward. So the answer are 1, 2. The answer 1 and 2 can be eliminated. Okay. So the answer is answer number 4 here. The volume is maintained a constant. Now let's look at question number 12. And the most you might have made a mistake. If so, just check that, okay? I'm not demotivating you. So I think I'll be giving thermodynamics question based on these, okay? And last class we discussed about cyclic process. I'll be giving notes from them. Now let's try to deal this question. And again, I'm saying it's a recording, okay? If you had any issues, let me know. Now they are saying the mass of the system is 8 kilogram. The mass of this system is 8 kilogram. There is a 20 Newton force acting at an inclination of 30. 20 angle acting at an angle of 30. An object of mass A. Object A of mass 8 is placed in a rough horizontal plane. 20 Newton force is acting with an angle of 30 to the horizontal. The coefficient of static friction between the plane A is 0.4. So here we are having 0.4. Now it is static friction, okay? Mu s. And they have given the dynamic friction also as 0.3. Now there are two things to be discussed here, okay? How this friction is going to exist. First point. First of all, let's find the friction. Now we are having the reaction force along here. To find the friction, it is reactional force into my coefficient of friction. Now what is my reaction force here? Is it equal to my weight in this case? Because in most scenario, even the question before this, we had it equal to its weight. But nicely look at here. You are having a downward force 80, 8 into 10. Additionally, this 20 Newton is also having a component. So be careful with that. So you'll be having 20 sine 30, which is 10 Newton. Okay, again I'm saying you, along with the weight, you are having the vertical component of this 20 and it is in the downward direction. So R has to balance 80 Newton and this 10 Newton. So my value for the reaction is 90 Newton. So this is the first point which I want to say, okay? Reaction will be every time not equal to the weight. There are certain cases, even in your inclined plane, there's a problem. You'll be having R equal mg cos theta. I'll just get you questions, okay, without saying these terms. So just remember this speciality, okay? You are having the vertical component providing the reaction. So my frictional force is equal to 90 Newton into, let's say the static friction is 0.4, 36 Newton. And my dynamic friction is 90 Newton into 0.3, which is 27 Newton. Now we don't know what is the friction. Let's see. Now you know that. Let me just erase this. Now the object is experiencing a horizontal force of 20 cos 30, which means 10 root 3. It is experiencing a horizontal force of 10 root 3. Now we have just have an idea about the graph, right? We'll be having a graph like this for friction with the force. Get that idea, okay? Now the friction is capable of giving a maximum value of 36 Newton. That is what included in here. This is the maximum friction it can provide. But will it be providing it every time? That will be a question, okay? The main motive of this frictional force is to make this object at rest. It wants to maintain this object at rest. Now if I give a force of 10 Newton, it is something like, okay, you have to pay rupees 36 to buy this object. But you are giving only 10 rupees. So this doesn't work. Now it does not provide this 36 Newton at once. It never provides that. What will happen if it does so? You are providing 10 Newton. The flow is giving 36 Newton. Now the main motive is broken, right? The object will start to move in this direction without moving this way. Clear? So get that idea, okay? The friction is capable of giving a maximum of 36, but it doesn't provide that. Only to the requirement, it will provide 10 Newton. Because inside 36, there's 10 Newton as well, right? So, equal to the force, there will be the friction acting. Equal to the force, there will be the friction acting until this point. Now, when you give a force of 36, this object can't move further. Okay? Actually, yeah, it can't move, but it will be at the verge of moving. When you give a force of 36, it will provide a friction of 36. When you start to give around 40 Newton, now this can't increase further. Clear? So now the object will start to move. Now there will be dynamic friction acting after this. So after 36, the dynamic friction, and it will be constant. You give whatever force, it will be the same. Okay? So get that idea. Until you reach the maximum friction, whatever you provide the force, the same force is provided in result. Then only you can maintain this object at rest. Okay? So that's the idea you have to get here related to friction. So get that idea. So I'm providing 10 root 3. Root 3 means 1.732. So my answer is something around 17.32 Newton. Okay. I'm providing a force of 17.32 Newton. But the object is having a static friction of 36. Now the question is, now you might think answer number 3 or answer number 4, answer number 2. Because we found that right 36 or 27. But again understand, it is capable of producing 36, but it does not give this 36 at once. Only to the requirement it's going to fulfill. So 17.32 is given. If I want to maintain this object at rest, I have to provide a force of 17.32 Newton. Not I, it will be the flow, okay? The friction will be providing that, okay? So just get that point, okay? This is what actually explained in your graph. So it's completely fine. You might sometimes mistake this reaction or sometimes get confusion with these forces. Until you reach the maximum, whatever force you apply is equal to your friction. If I provide 10, it is 10. So your answer has to be 17.3, answer number 1. Okay. Now you might be thinking, okay, the object is not moving, you'll be having static. That's the point, you make the mistake, okay. So if you look at the last question, question number 13, question number 11, 12, yeah, 13. Okay, so all okay with this. The last question. In here, I'm mainly expecting two things. One is the ability to draw graphs. So, if you want to draw graphs, you should know equation. Now we are going to construct that equation. And as already I said, the maximum and minimum point is discussed. So just look at that. If you look at here, there is a certain wedge along here. The ball is going to be rolling towards A to B. So there's reaction at A. There's reaction at B. A uniform and heavy. Uniform means the weight is acting in the middle. A uniform and a heavy plank AB is kept horizontally on two supports. A heavy cylinder is placed on plank A and it is rolled over towards B. The variation of reaction in the plank A to B. So they ask me what is the variation of reaction A and reaction B when the object is rolling. So how are you going to actually think this? Now what you can do here is, the object is moving from A to B. Let's say the object is at a distance of x. The object is at a distance of x, which means x is the value which is increasing up to L. Now let's take moment from this point B. See, A. If I take moment from A, I'll be finding that mg into L by 2. If the length of the rod is L, let's say 2L, so it is L. You can say that now this is having a simple mg. You can see that capital mg into L plus simple mg into x is equal to rb into 2L. Moment about A, clockwise is balanced by anti-clockwise. So from here I'll be obtaining an equation for RB. RB is equal to mgx over 2L plus mg over 2. Okay with this? Now get an idea. We are required to draw the reaction with the displacement. So The reaction is here. Displacement is what I have included as x. I'm having a format like y equal m. Don't take m, okay? Let's say k. K means a constant. K x plus c, which means y equal mx plus c. M is the gradient. In here, k is the gradient. C is the constant. Because the mass does not change, right? So this part is a constant. This part is also a constant. So get that idea. I should have a format like this. Starting from an intercept, it should increase. Starting from an intercept, it should increase. So answer number 3 is wrong. It is starting from the origin. Answer number 4 is a curve. That's also wrong. So answer 3 and 4 is gone, okay? Let's look at the other one. Now nicely look at here. You know, for equilibrium condition, RA plus RB has to be balancing capital Mg and simple mg. Capital Mg plus simple mg. Okay. Total upward forces balances total downward forces. Now if RB is this answer, I can substitute onto here. RA is equal to mg plus simple mg minus mg x over 2l minus capital Mg over 2. So my resulting answer is capital Mg over 2 minus plus Mg minus simple Mg over 2L into X. Clear? So you should understand this part is a constant and it does not have any X term. So Ra is equal to C plus, this part is a constant because mass is not changing, right? Anyways, it's a constant plus, now be careful, it is mg over 2l, that is your gradient, let's say m naught, but it is minus of x, so we are having a minus here. So this is something like a format y equal c minus mx. Clear? Y equal c minus mx, which means it is having an intercept. Here also I have said c, okay, it is c1, it is different because the intercept here is mg over 2, but the intercepted here is greater than that, mg over 2 plus mg. This is mg over 2, I'll say c, okay, c. This is what something around c1. So y equal minus mx, so I should have a graph like this. Clear? So this is the basic way on how you draw graphs. You see an equation first of all, then you start drawing these parameters. So that means after that you will be able to see what is the intercept, what is this m and those stuff. Now, until now we have deal only with this m, okay, which means a constant gradient. So we'll be having straight lines. So if you are okay, just let me know. I'll be giving you curves, okay. If you are still confused, I'll give you more questions. So let's wind this then. And this is the reason. Now I just plan to record the session, but there were no students actually around, but in the online class, maybe for network issues, some had network issues and some had time slots. They used to watch the recording. So if I just record in the Zoom, the quality is not that fine, right? So that's why I recorded from my mobile, and it is actually broken into pieces, okay? So you can just watch them. This is the answer for question number 13. You are having a y equal minus mx format for RA, whereas RB is having a mx plus mx, okay?